So what happens when a factor in the denominator cancels? So we talked about this situation a little bit. We said, well, this is equal to x plus 3 over x plus 3 times x minus 3. And we said, well, those factors are the same, so they can cancel. So now we have rewritten our function to be 1 over x minus 3. Okay, but we still can't have negative 3. X cannot be negative 3. And we know there's a vertical asymptote at x equals 3. Okay, because you're still going to have x be 3 or negative 3. So what does it look like when you're graphing it? So we'll do a quick little sketch here. First of all, this is what we're graphing now. We just have to remember, though, that x cannot be negative 3. Now, what is that? That's the rational, uh, the reciprocal function. Sorry, it is a rational function, but the reciprocal function. Reciprocal function. So we kind of know what that looks like. But it's got a transformation to it. It's shifted 3 units to the right. Okay, so it's going to go 1, 2, 3. We know there's a vertical asymptote there. And you could put that in a different color. And then think about, what did we get before? Well, remember we had 1, 1, but now see it's 4, 1 because it's shifted over. And then we said it goes up quickly this way, and then it's kind of going down like this. And it looks something like that, right? And then we said, well, there's another part over here that's going up this way and down this way, right? Okay, now I didn't draw all of it to the left there for a reason. We have to remember that x can't be negative 3. So we know how this graphs. We know the basic look of it. But what we have to do is we have to put a hole there. It's going to approach negative 3, but it can't actually equal negative 3. And that continues on. So there's like a hole in the graph. I mean, it's not very pretty. It's prettier in the book. You can look at these graphs in the book, but that's what's happening there. So it's like we did simplify it. Now we're graphing this function, what that looks like, which involves a transformation of the reciprocal function. So we scooted it over, but we have to remember that you still can't have x be negative 3 because of the original function. And so it's like punching, it's like a hole punch. You're punching a hole in the graph. Let me give you another example because this is kind of a short video. Let's say you had f of x equals x squared minus 4 over x minus 2. So you say, oh, x can't be negative 2. Well, you're right. X cannot be negative 2. But we're not going to get a vertical asymptote. What happens here is you factor the numerator, x plus 2, x minus 2. And then you see that those cancel. There is a common factor, right? So now it has simplified just to x plus 2. Well, that's a linear function. We know what the slope is. We know what the y-intercept is. So we'll count up 2 with the y-intercept. The slope is 1. So remember how to graph a linear function, I hope you remember. And so we have this line that's going to happen here. But x cannot be negative 2. So at negative 2, let's see, what would it normally be? Down 1, back 1, down 1, back 1. There's going to be a hole, not a very good hole, like that. And then it continues on. It's linear. Well, it's not drawn very well, but there's that hole right in the line, okay, at x equals negative 2. Okay? All right. Those are a couple examples where that has a common factor, and what we do, we simplify it. We graph it like with the normal graph, except where the factor that we canceled, that is going to have a hole in that spot.